Hi, Professor Bob Young back at you again, and in this instructional video, we're going to look at some properties of logarithms. Now, since a logarithm statement can be written as an exponential statement, it is not surprising that the properties of logarithms are based on the properties of exponents. The properties of logarithms allow us to change the form of logarithmic statements so that products can be converted to sums, quotients can be converted to differences, and powers can be converted to products. Now we're going to assume this first line on just about all of these properties for all x and y and a greater than 0, with a not being equal to 1 and any real numbers are here. This first rule, Young is going to call log rule number 1. It's the product rule. So the logarithm of the product of two numbers is equal to the sum of the logarithms of the numbers. Now we're going to find this extremely useful here for a lot of different things down the line. So Young is going to call this log rule number 1. Now remember, your calculator has a common log key, base 10. So we're going to write the log, and we'll just test this on your calculators. You can take those out, of 8 times 3. So that would be 10 raised to some number will give you 24 there. And then go ahead and put that in your calculator and hit equals, and you'll get a number. See if that then equals the log base 10 of 8. Now, of course, 10 is unknown there. It's just because that's the calculator-based number, plus the log base 3. I think it's probably because we have 10 fingers that's true. But anyhow, you will get the exact same answer to both this and this, digit per digit, on your calculator, or it's time to take it back and return it. The second log rule, Young's going to call it log rule number, I bet you guess what, 2 is the quotient property. It says the logarithm of the quotient of two numbers is equal to the difference between the logarithms of the two numbers. So again, on your calculator, knowing log means base 10, go ahead and try some numbers here. You can put in any numbers, the log of 12 divided by 5, and I bet you will get the same exact numbers digit per digit if you do this log 12 minus log 5 and verify that rule. And the final log rule, there's only 3 of them besides, that's not too bad, is called the power property, and it says the logarithm of a number raised to a power is equal to the exponent multiplied by the logarithm of the number. So for example, let's stay with our base 10 on our calculators here. We'll play some more. The log base 10 of, let's say, 5 to the 4th power will equal, you can take that 4 and write it out front. It will equal 4 times the log base 10. Oh, I put 2 logs in there. Double log. I had a log jam there for a second. Hang on. All right, so it'd be 4 times the log of 5. So again, just try that with 1 log here on your calculator, 4 log 5, and then log 5 to the 4th power, and again, you'll get the same number. So 2 additional properties of logarithms to follow from the definition of log base ax, since a to the 0 equals 1 and a to the 1st equals a, then the log of just about any base 1 will equal 0. Why is that? Because if we wrote it in exponential form, I don't care, as long as that's a positive number base there, any base to the 0 power will give you 1 there. So the log, and if you try this on your calculator, the log of 1, and even though your calculator is base 10, I bet you it'll say 0. And notice here, if you have the log of the same base numbers, a to the 1st equals a, try this on your calculator. It will tell you the log of 10 is 1 without a doubt, because it knows there's a little 10 down there, and it knows that 10 to the 1st power equals 1. So again, logarithms are nothing but exponents in disguise. All right, let's have some fun with these properties and rules. Rewrite each expression, assume all variables represent positive numbers, and so forth. We're going to take the log base 6 of 7 times 9, and we are going to rewrite that using log rule number 1 here. So notice we're just taking the multiplication and rewriting it as addition. So they will give you a lot of stuff to do in the exercises to use these 3 rules of logs until you get it. Okay, this one, log base 9 of 15/7, we're going to need log rule 2. And we're just going to take the division. Whenever you see a log of anything that's divided, rewrite it as subtraction. There's your quotient rule. And also be careful of radicals here. Now, I planted this seed for a long time, probably since chapter 1 when we did radicals here. But it's the old E over R again. That square root of 8 is going to cause problems. You must always simplify radicals into fractional exponents. So notice I'm going to write the square root of 8 as 8 to the 1/2 power. Now remember, E over R always means exponent, which on the 8 is a 1, divided by the root number. So in this case, a square root, you'll get 8 to the 1/2. And whenever you have a log to the 1/2 power, this is log rule number 3. You take that exponent and you write it in front. So the final answer would be 1/2 log base 5 of 8. And then, ladies and gentlemen, I'm afraid they get really nasty with some of these. But again, don't panic, all right? Look at this one. The log base A of this gargantuan fraction, mnq in the numerator, divided by p squared t to the 4th in the denominator, all right? Now, what they did first in this first step is they used log rule number 2. So I'm going to write these rules so you'll know what the heck we're doing here. And they took this division here and wrote it as subtraction. So they took the log base am plus the log base an, and also notice they used rule number 1 here as well. So they used both rules 1 and 2 right away here. So they wrote all the multiplication as addition in the numerator and the denominator, and then since it was divided here, they put the subtraction symbol in the middle. So be very careful on these, and it says use parentheses here to avoid errors. All right, next they went from here to here using log rule number 3. So these exponents noticed inside this first parentheses is now moved out front here. And then all they did from that point on, and I'll go with some different colors, is they took this minus sign and distributed it here for the final answer. So when you have a total final answer here, if you're using these properties of logs to take one single log, so here's what we did. We took one single log and we broke it into a bunch of little logs. You want to, make sure that when you get the log base A of something plus the log base A of something plus minus whatever, that you just have a single variable here on the end. And then depending on the exponents on your variables, you notice up top here, we had all first powered MNQs. And in front down here, we've got all ones in front of the MNQs, while as when we had a 2 on the P, a P squared, and a T to the 4th, that shows up in the answer as well. So it is fun to take a single log and break it into a lot of logs. Now this one might look a little bit easier after that last one. So in part E here, again, we're using the old E over R rule. So we're going to take this cube root of m squared and write it as m to the 2/3 power. Again, E over R exponent divided by the root number. And then using, this is log rule number 3 here, you can take that 2/3 and move it in front in terms of multiplication, the power property, your book likes to call it. What's that? You need more fun with radicals? Now, I don't really like the way this problem is laid out here. Now, I guess it's all right. I mean, they took this square root of n, and kind of what they did here is they put this giant parentheses around it to the first power. So they went ahead and took this and wrote it as terms of E over R here, 1 over n power. They then moved that in front of the log and put that to what was inside here. Okay, so this is power rule number 3. And then they used both rule 1 and 2 here. Notice they took the multiplication, rewrote it as addition, the subtraction here, the division, and rewrote it as subtraction. So this one they're just going ahead as these get more difficult and breaking these log rules. You're going to think you're in a log jam here pretty soon. And I bet you in the next graphic, we're probably going to have to do something with these exponents. So you know you're not done as long as you've got exponents on any of your, I guess, the arguments following the log of whatever base is there. In this case, base B. So notice that's exactly what they did. They went ahead and wrote 1 over n, and then they moved the 3, the 5, and the m using log rule 3 here from the previous graphic. And then it looks like they went ahead and distributed the 1 over n through to get this final answer. All right. Now, some of you may have done this from the very start. All right. That was one way to do it. What I might have told you is if you know your E over R well, you could have also written this log base B, and I don't know if anyone saw this, but if you did, kudos out there. And then X, I would have put to the 3 over n power, Y to the 5 over n power, divided by Z to the m over n power. And that was just one swoop of the E over R without having to take and make that whole thing 1 over n there. I don't know. Now, some of you are going, Young, why didn't you just show us that before? Sucker. Sorry. But anyway, if you did, you might have got here a whole lot quicker. You know, so watch out for what you're doing and try to have a little fun with it. All right, more examples. Write the expression as a single logarithm. Now, there's only one thing more fun than taking a single log and breaking it up into a bunch of little logs, and that's taking a whole bunch of little logs and putting it together into a single log. So notice here we've got some plus and we've got some minus signs here. So we went ahead and we combined these two logs since they had an addition with them using log rule number 1. And we wrote that addition on the numerator here, and I like the way they put the pretty colors blue here, all right, as multiplication. And then when you have the subtraction with that same base in the 2, that gets written using log rule number 2 as division. So not only can you break up logs, you can also put them together in terms of one log. Okay, here's another example. Now, in this one, we've got 2 log base am minus 3 log base an. So if we're going the reverse order, notice these numbers get moved as exponents here. So we're kind of doing the reverse order here. We're seeing numbers in front. We have to use log rule 3 to write them as exponents. And then with this minus sign in here, we're going to use log rule number 2. So they're going to get you coming and going on those 3 log rules. Can you take them apart? Can you put them together in terms of a single logarithm? And they'll make them nastier and more vicious here. Lots of examples in Young's videos. We're going to take this 1/2 and 3/2 here, the numbers in front, and we're going to use the 3rd rule and write them as exponents here. Now this 3rd one, it looks like they kind of have put together there for us, don't they? All right. So I'm noticing once I do log rule number 3 here, and I'll go ahead and put that, the next thing I might want to scope out is the old positive and negative. So I'm thinking some multiplication and divisions coming here real shortly. And sure enough, this multiplication here, and remember they took that 1/2 and they put it here on the m in the previous graphic, and they put this 3/2 on the 2m. Now, watch the parentheses there. And with the plus sign, we've got multiplication in the top. With the minus sign, we've got the division in the bottom. And let's see what else we got going here. Oh man, do you see how they went from this step to this step? They kind of long jumped there. All right. Now, how in the world did they do that? Well, 2 to the 3 halves power n to the 3 halves power. If you raise both 2 and n to the 3 halves power, you're going to have that. And then, oh, they skipped some steps here. I don't like when they do that. M to the 1/2 power. So I'm taking this right here. Oops, sorry, my writing tablet's getting strained here. And I'm going to divide this by m squared n to the 1st power. So notice we've got some subtraction of exponents here. So they did some power things here. So 3 halves is another way to write 1/2 minus 1 on the ends will get you n to the 1/2 in the numerator. You've got m's here. You've got 1/2, which was over here, by the way. Hang on a second. Over here, by the way. So I'm going all over the place here. I hope you're making sense of this. And then the 2 on the m here, that's 2 over 1. Now that would be 4 over 2 if I got a common denominator. And now my puppy's over here growling at me. He wants to play. I'll get to you in a little bit here, puppy. I'm almost done with this video. All right. And then we'll get a positive 3 halves here on m in this problem. So those 3 properties, going to have a lot of fun with. All right. And we'll just look at some more examples as we go on here. So notice on this one, they went ahead and once you get everything here in terms of the 1/2 power, they went ahead and changed the old e over r here to the square root of, and they changed the 2 to the 3rd power into 8 here. So they went ahead and wrote it as a radical answer to finish it off. So boy, these are just getting all kinds of fun here. And now my puppy is scratching my arm. All right, now here's one thing to watch out for. There is no property of logarithms to rewrite a logarithm of a sum or difference. That is why in some of these other examples we've looked at, watch out for this. The log base 3 of some quantity x plus 2 was not written as log base 3 of x plus log base 3 of 2. Remember, that first rule only works in case of multiplication. Can you do that? So you cannot distribute across logarithms or it could be trouble. All right, finally, the last example here. We're going to be given an example that says assume that log base 10 of 2 equals 0.3010, and it wants us to find some things here. Find the log base 10 of 4. Now, if this is all we know, and they just gave us this, and now they're going to jerk our change with some exponents here, we can write 2 as 2 squared. We could use log rule number 3 here. Oh, so those log rules are just going to twist you every which way here. And you can write that as 2 log base 10 of 2, which up top they said that this is equal to this number to get this answer. Log base 10 of 5, well, how are we going to get that in terms of 2? We would have to say that is 10 divided by 2. And then we could say the log base 10 of 10 minus the log base 10 of 2. Now here, log base 10 of 10 is this number 1 minus this. So see, you're going to give you all kinds of tests here for your logarithms. So be ready and be tough. All right, now the theorem on inverses. Everyone's going to want 1,000,000 questions on this, and we're almost done. This is, I know, one of the longer videos, but this is the more difficult material toward the end, so I'm trying to give you a little bit more on these. Notice if you have a raised to some log with that same base x. Since logarithms and exponents are inverses, they undo each other, and you get that answer. Or if you have the log base a of a to some power x. Now think of the clown face on this one. You can see this one a little better. that you will get the answer of x. So these kind of undo each other, and it'll make a little more sense if I put some numbers in here. So in other words, let's look at this first example. I'll say it again. Been doing a lot of videos today. I'm getting a little tired here. 7 raised to the log base 7 of 10 will give you 10. See, so look for these base numbers to be the same, and it'll pop right out of there. Again, if you have log base 5 with the same base 5 raised to the third, it pops that 3 right out of there. And it works for just about anything as long as we're talking about correct things we can put in there. So the k plus 1 comes out of there. So a lot of you will want some of these, I think, on the test. And again, here is the total handout that's in your care package. And looking at these here, we can do one more here for you before we sign off. Let's take 4 log raised to the log base 4 of 15. That will give you the number 15. All right. So use that handout and use it well. Bob Young signing off. We're getting toward the end.